In this video, we're going to be looking at integer and floating point variable types. Okay, just as a very quick review, there is a cross-topic link here in the course close to this video that goes into integer and floating point types and how they're encoded and all that other kind of stuff. But very quickly, an integer is a whole number that includes 0 and negative numbers, and a floating point number is the same thing except it includes a decimal place. It can have, like, fractional values and things like that. So that's pretty simple. So let's go back to the program that we've been building up on here in this topic here on talking about variables. And so far through this topic, we've been using ints to talk about integer, or to talk about declaring variables and initializing variables and assignments and everything like that. So you've seen pretty well how they've worked, and again, we've been using int for the integer type. So that's pretty much what we're going to use for integer types in this course. Okay. For the floating point type, however, we haven't really looked at this in this course. We're going to use something called a double. Okay, so let's declare a double. A double equals 0, and I'm going to put 0.0 here just to denote that, yeah, it does have a decimal place. It really doesn't matter, but this might kind of help you to remember, yeah, okay, this has got a decimal place. As far as the compiler is concerned, it's not, or the program is not really going to make any difference whatsoever. But some folks really like to do that. Doesn't matter, but this might help you to remember here, since I've done that. Later on in the course, I may start initializing them with just zeros. But you may be wondering, okay, that's great. Int is short for integer. How in the world do you get double out of floating point? Well, just as a quick little demonstration, let me type float. Okay, notice how it turns blue. That's because this is a keyword. All right, it's part of the vocabulary. Keyword is part of the vocabulary for C++. Now that makes a lot more sense, right? Well, it used to be that even these were, could really slow a program down, because you'll read about, or have read about earlier in the course when we were talking about integers and floating point numbers, the floating point numbers take a lot more memory and processing power, and so anytime you needed a decimal point, this was your go-to. Okay, and even it would slow it down. You would only use a double if you really needed that level of precision. Well, of course, that was a long time ago, and now it's not really so big of a deal, and a float doesn't exactly give you a lot of precision. So a double is actually like a double float. I've heard it referred to as a double precision, whatever. So that's where double comes from. If you have any trouble remembering this, just think of a double float, like a double root beer float. So if you're trying to remember what is a double again, or what am I supposed to use for that float, just think double root beer float. Okay, and so you can remember double that way. All right, so let's get rid of that. Now we're getting a tad bit of length in here where we're building on this program for this topic. So let me add a comment here that says let's see, initialization, and because I want to leave this in here, initialization and assignment, because that's where we were using those. And so that our output we don't end up with a whole lot of stuff coming out, and so okay, now what was this, what was that? To eliminate confusion, I'm going to comment out. And that whole idea of commenting out, I'm going to comment out this line so that it will not be compiled and everything, and so that it will skip that output. Okay. So then we'll come down here, and we'll have numeric types. Okay. And we're going to want to output. Remember, we'll get to this exact syntax, but you've seen it so much in all of these examples. This is just going to output what it's just going to output the variable here. You know that much. When we get to this, I believe it's in the next topic. See out. It is in the next topic. You're going to be like, oh yeah, we know how see out works. We don't even need you. Well, there's some stuff that'll be explained in there about it, and some nifty little things you can do with it. My double. So this is going to output our values here for what we're talking about. All right. So we have initialized everything to 0. However, in all of our initialization and assignment, if you remember from the previous video, we ended up where these two integers had a value of 5. So we'll see that 5, and then we'll see the 0 output for my double. Okay, let's go ahead and run this. Okay, so there's your 5, and there is your 0. Alrighty, so let's just show that again. If we change this to equals 6, let's say 6, and my double equals, let's say something like 3.3. Okay, now this is all pretty straightforward. So doubles work pretty much just like ints. Oh, by the way, I did mention that whole float thing. There is a link to a great resource, c++.com, and that link is to a specific page. There are, more numeric types, and it outlines that whole exactly how they're lined up as far as how much memory they take and all that other kind of stuff. So if you're interested in that, go take a look at it. It's just that in this course we're going to be using well, let me scroll back up here. We're going to be using the int type for integers and the double for the floating point type. So yeah, as I was saying, a double is going to work just like an int, except it's got decimals in it. So if we go ahead and compile this, remember we're going to output so then you got 6 and 3.3. See, nothing to it. Now there's something a little strange here that we need to show, and that is, what if you say my double equals, what if you try to assign to it an integer? What happens? Okay, just remember, with assignment, it's value on the right assigned to the variable on the left. Well, an integer is just a whole number, right? Well, and 0 and negatives, everything. So alright, it doesn't look like there should be any big deal here, and there's really not. There you go. So remember, the first one output is the integer, the next one is the double. In reality, this double has a 0.000, whatever after it. Okay, so, but yeah, it's a whole number, and you put it into a double, it's 6. Okay, sitting here going, okay, yeah, that's just a little too obvious. The reason I did that first was, let's comment this out. I want to leave it there in case you're looking at stuff in the source code reader. But instead of that, let me make this a little tighter there. So it's a tad bit more clear. All right. All right, if you go the other way around, though, something interesting happens. Let's say my int equals my double. And this is very important for you to remember, okay? And you've seen it in the course. We went through a big, long explanation of all this, but let's just do it in the video here. Now what's going to happen? You're assigning 3.3 is the value of my double, and you're assigning that to int. And it's like, okay, great. Well, it's 3.3, so don't worry about all that stuff coming up. Yeah, we're not going to. It has to do, that big long stuff has to do with the way doubles are formatted and binary and everything, so don't sweat all that. So anyway, we're just putting 3.3 into my int. All right, well, pretty obviously you say, all right, well, 3.3 rounds to 3, right? Well, it does, and if we check out what happens, then yeah, see, so now remember the first one is my int and the next one is my double. So yeah, you're right, it's 3. So why is such the big deal? Well, what happens at 3.5? Okay, if we put 3.5 in here, is it going to round up? Is it going to round down? What's it going to be, right? Well, let's see. Is it going to round up or down? Okay, it's still 3. Remember, this one is the integer. This one is the double. Yep, it's still going to be 3. So let's hit any key to continue. There we go. And all right, no sweat. Well, so if we change this to something like 7, it's going to round up, right? Okay. Yeah, let's double check that. Yeah, that double is 3.7, but it's still saying that int is 3. Is there a problem with our program? No, of course not. And as a matter of fact, we can change this to 3.999. Okay. Go ahead, recompile. And yep, that double is 3.999, but you assign that to the integer, and we've still got 3. Okay, so that is the big point, and everything in this video is pretty straightforward since we've seen ints so much, and doubles work just pretty much the same way, except they have decimal places. No biggie, right? And if you assign an integer to a double, okay, doesn't really matter because they're whole numbers anyway. It just, okay, it is that. However, you do have that issue here where it doesn't round. Of course, there are ways to make doubles round however you want and all that kind of stuff. But what is it doing here? It's doing something called truncating. So if we go back and look, run the program again, and we're right here. So by truncating, everything after the decimal point is just going to go away. It's not going to round anything. It's just going to take that away. That's all it is. It's truncating. And the reason for making such a big deal out of that is, you know, you might, in your program logic and everything, you need to realize that that number is not going to round, and that going back and forth between doubles and integers isn't necessarily so straightforward, because you know, you can really lose some stuff. So you really need to think about your numeric types. Okay, do I really want a floating point number? Let me go back here. Do I really want a floating point number, or is a whole number really what I'm looking for? Okay, and that's the whole thing, because you may have been wondering at this point, it's like, oh, well, you said that double doesn't matter. Why don't we always use floating point numbers? Well, well, there's a couple of reasons. One is this type of thing, yeah, this type of thing, where it's going to be truncating. Those things you can keep in mind, and it's really easy to end up with something that's like way off because of this. But yeah, just for your information, it also turns out that integers, there's something called integer math, so it works a little differently, especially, as you might imagine, with division. So it does something similar with this whole truncating, and there's an extra operator and all that kind of stuff. We'll get to that in topic 7 here in part 1, so it's a couple of topics away. But not only that, okay, but as you will see as you progress through the course, there's just a lot of places where you want integers, okay, because it just fits in with your logic. All right, so still, anytime you need a number, you may not automatically want to go straight to a double. All right, and still, it is still true that integers are a whole lot more efficient, especially if you don't need, all of these decimal places. So that's the big takeaway from this video, because, working with doubles isn't much different from working with ints, and you've seen examples of ints already. It's all very, all of this stuff, it's all very straightforward, but it's just something that you really need to understand when you're talking about ints and doubles, okay, that a lot of times you just will want an int, and that if you start mixing them together here, if you start mixing them together here, you can end up with that situation of truncation. There could be a logic situation where you want that truncation, but anyway. All right, so that about covers it for numeric types. Again, there's a link to C++.com where you can look at other types, but int and doubles, what we're going to be using here. And there's a cross-topic link somewhere close to this video if you want to go back and review or find out more about integer and floating point types. Okay, let's make sure all of this is saved. All right, in the next video we'll look at another type that's called a char. All right, and we will see you there. This concludes another video for Introduction to Programming with C++, brought to you by LogiKomp. You can access the full course by going to the course homepage at logikomp.com/introcpp. While we are proud to offer this course free of cost to individuals, we do ask that if you continue to use the course, that you support its production and maintenance by making at least a small purchase from LogiKomp Domains and Hosting. You can pick up a custom domain, renewable annually, for around $10 at logikomp.com/hosting. Thank you.